sure that you all know Jose needs no introduction, but I'm going to introduce him anyway. I'm sure you know him as the creator of Elixir and Plug. He's also a co-founder of Dashbit. But if you've been watching the conference, you see the impact that Jose is making on Elixir and Elixir is making on the world, and that's a high compliment. So welcome, Jose.
Thank you. Thanks for having me. Francesco, I'm not going to take up your challenge with the t-shirt, but I have a good reason. It's because I keep all the t-shirts for all the Elixir conferences I have ever been, and they're all in mint condition. So I cannot choose a favorite. And I have like all the Elixir confs in the United States here. Here I have all the Elixir confs in Europe, Elixir Brazil. So just wanted to share that before I get started.
Okay, so you win the prize. All right.
Excellent. So I think that I'd like to start things off by saying that open source software is really about people. So Jose, is there anybody in particular that you'd like to thank for their work on Elixir NX?
Oh, yeah, that's a good question. I believe there is a lot of people I would like to thank. But I'll tell a story and that's going to show how a very brief story. So I have always, my thesis that I wrote more than a decade ago was actually on machine learning before neural networks, the deep learning was a thing. So I always had this interest in like, well, Elixir needs to go to multiple domains and I always wanted machine learning to be a thing, but I never really knew how to get started. And it always started, this work on an X always started when Prog announced a book called Genetic Algorithms for Elixir. And who wrote this book is Sean Moriarty. And then I reached out to him like, hey, you seem to be interested in AI, you seem to be interested in machine learning. And he was like, yes, I'm definitely interested in that. And then we started talking. I did a tweet, a very random, very vague tweet after I started talking to Sean. And then I met Jacko. He's from China, and we started exchanging some messages as well. And he pointed me towards a library called Jax, which is we got a lot of inspirations from. So from this short story, you can see that I would like to thank Prog for giving the opportunity to authors for publishing their book, because if they did not publish the genetic algorithm book, I don't know when or if I would have met Sean, and definitely without Sean this would not have happened. And then the people that assisted us like Jacko, and then we are starting something new, but we are building on a lot of projects like NumPy and Jax, both from the Python ecosystem. So we have places where we can look at and say, hey, how can we do this, or what should we do and what should not do, that are open source and inspirations for us. So yeah, a lot of people to thank. A really special thanks to Sean, because without him, none of this would have happened. And yeah.
Yeah, so it's kind of a crazy thing, right? You've got this machine learning concept, and there's all this mathematical jargon swirling around it, but at the premise is pretty simple, right? It's that you have a model which is just a configurable function, and the function has these weights and biases that work on knobs and levers, and then you kind of put that through a training process one or more times, and the function gets better at making predictions. But there's a lot buried in there that has some particular challenges for Elixir before this announcement happened. So what are some of those challenges, Jose?
So I've been ramping up on a lot of this stuff. I think the first initial hurdle that the hurdle that everybody talked about was the hurdle of well, it needs to be fast. We need to have we need to talk about numerical computing. And the thing is that a lot of times, like, people would say like numerical computing in numerical computing in Erlang and in Elixir is slow, right? Like if you're not familiar with the background, you say like, hey, does it mean that like the integer operations are slow or the float operations are slow? That it's not that precisely. It's rather that when we are working with this stuff, what we are doing is that we are working with large arrays of data. And usually they are multidimensional, right? So you can think like large matrices. So if you think like a photo, for example, right? Like let's take a photo, a image, right? We can represent that as a three-dimensional structure where you have the height, you have the width, right? And you have three channels, usually RGB. And that's a three-dimensional structure that we use to represent the image, where each point in this three-dimensional structure is a byte, right? That's one of the ways we can represent that. So you know, a image can be 20 megabytes, 30 megabytes. And then in Erlang and Elixir, if everything is immutable and I need to change one pixel in that image, right? It means that, or even if I'm going to traverse that image somehow to do some modifications, some smoothing, some blurring, whatever, you are copying everything, right? You make a whole copy of that really large thing. So you know, it's actually about working with like really large data structures and how can we make that efficient. So that was always one of the big questions, and it happens that, and one of the ways you can do is like, hey, you know, we can compile to native code or we can compile to something to the GPU. But something that has happened in the last years is that we are starting to have those things that they call tensor compilers. So tensor is how we call these multidimensional data structures. And you're usually working at a high level API, say, hey, you know, I want to reduce over this multidimensional structure on this particular dimension. I want to reduce as a window that is looking at some of the pixels in the image or some of the bytes at a particular point. So so we start to have those tensor compilers that kind of provide those high level operations for you. And they can compile to the CPU for you. They can compile to the GPU for you. So basically what it means is that when we started tackling this problem, we could have gone to the approach of like, hey, we can get some Elixir code and compile it, just a second, and we can compile it to run on the GPU. But everything is moving to the direction of these higher level compilers. So and if we say like, hey, we want to compile everything to the GPU, that would solve the first problem, which is how to make things faster. But the next problem is going to be, we need to create all those libraries, all this huge ecosystem of operations that you can do all those tensors. So by targeting those tensor compilers, we kind of solve two problems at once. That was one of one of the biggest hurdles that we have, and that was one that we tackled very early on. So when Sean started working on this, so we have a project called EXLA, which are bindings for Google XLA. And XLA, the Google XLA stands for Accelerated Linear Algebra. It's a tensor compiler. It's a technology that can get high-level operations and compile to very efficient code. So that was one of the first things that we tackled. And I think like Sean worked on it for like 2 weeks, and he already had like some code running on the GPU. That was when I first tweeted the benchmarks, where, you know, things were like, if we compare like some regular Elixir code with this accelerated code, it was like 300, 400 times faster. And that was like the initial attempt. But again, like that's the first hurdle. Then the next hurdle is, well, if you want to talk about, as you're saying, right, like if you think about a neural network, what the neural network is something that you give an input. So for example, if you're doing image classification, you give an input like, hey, this is an image. Tell me if it's a dog or a cat, right? And it's going to give an output that says, hey, you know, it's a dog or a cat. It's going to give you a number usually representing if it's going to be a dog or a cat. But the thing is that the neural networks, when you start with them, they don't know if something is a dog or a cat. You have to train it, right? So what you have is that you have a function that has the input and the output, and it has some parameters in this function. And your goal is to change those parameters. So when you give a cat, it says it's a cat. When you give a dog, it says it's a dog. And And so one of the things that you have to do in neural networks, and that was one of the other big hurdles, is that you need to figure out how to customize those parameters. So one of the ways that you do this is by doing something called gradients. There's a long story you can go here. I've talked about this, so I don't want to go a lot in detail on how gradients work. But if you think that a neural network is a mathematical formula, you need to compute the derivative of that formula. And that's something that the NX library does for you as well. And all the major neural networks libraries, they do for you as well. So that was something that that was another big hurdle that we have to implement. I started working on the grad, and I think before we release it, I refactored it 3 times, I believe, that part of the code. And it's very funny because I have a degree, and my degree is in automation and control engineering. But before I graduated, I was already programming. So I kind of knew that I would not use that for anything. I was able to do my thesis on machine learning, but I was usually like studying, engines, electronics, and this kind of stuff that I forgot about everything, right? So for a long period of time, I thought, well, I'm not going to use my degree for nothing. And now that we start implementing these derivatives kind of things, I'm actually using something that I learned in university, but it's something that I learned like on the first year in university. So now I need to find some value for the next 4 years. But the first year is guaranteed, it's covered. Yeah, so those are kind of like the initial hurdles. I think like if we wanted to start the conversation about numerical Elixir, those are the basic steps. I think without that, we could not really start this conversation. And of course, it's not the end of our hurdles either. So right now, what we are doing is that so now, because when people are building neural networks, the models, they are so large, is that what you need to do is that you need to do like distributed training. You're actually not training it with a single GPU. You actually have like 8 GPUs that are running at the same time, right, to train the neural network. So the next hurdle that we're going to solve is exactly distributed training. And it's funny because distributed training here means something completely different from our distribution, because we're not actually sending data between nodes. We are sending the data directly between the GPUs. But we'll try to see how much of our abstractions we can bring to this domain to make it familiar for Elixir developers. One of the nice things working on all of this is that, for example, a lot of the things that we're doing, they have bindings for Python. So we often look at how the Python code works to bring that in. And it's really interesting because for the Python code, they have to do a lot inside C++. So like they need to create thread pools to control how you're going to communicate with the GPU and so on. And with Elixir, thanks to the Erlang VM, it's so nice that we don't have to do any of those things in C++. You're actually, hey, oh, you need a thread pool? We're like, no, we're just going to create a process that is going to represent the communication for that particular GPU device. So we get to write less C++ code. Which for me is a plus. So yeah, there are many hurdles ahead, but yeah, and we'll continue working on them.
Wow, you've already set the table. I had like 6 or 7 questions kind of laid out for you, and you kind of answered them with that first one. So let's start to take some questions from the audience. One is from our mutual friend Zaki. I think has Zaki been to every Lone Star Elixir or Elixir Conf in Austin that you'd ever attended, Jose? I think it's got to be close, right? So Zaki's question is, in your Thinking Elixir podcast, you mentioned 2 other surprises coming down the pipeline, and this has 9 votes. You don't have to answer this, Jose, but he asks, could you expand on these 2 surprises and their timelines?
Yeah, so I'll just recap what we have publicly available right now. So we have NX, which is this multi-dimensional array abstraction. We have XLA, which are EXLA, which are bindings for this Google Tensor compiler thing. And last week, we have merged a library called TorchX, which is bindings for PyTorch. So TensorFlow and PyTorch are the 2 biggest libraries for machine learning. And TensorFlow uses XLA and PyTorch uses libtorch. So now we have bindings for both of these abstractions, which is really important for us to both bring like alternatives for us to play with, and and for us to start leveling the playing field, so we can have the same foundations and abstractions that the Python community is using, for example. And then the two other projects, we are not super ready to talk about them yet. It's so I think Zaki, he said one is the equivalent to pandas. So pandas is for data manipulation, especially if you want to work like with tabular data. And the other one he said is matplotlib. So those are not the things that we are working on. But those two things, they are very, very important. So we need to have good plotting libraries. And we know we already have some that are context that is very good for the context of live view. But usually when we think about plotting for the web, it's a little bit different from numerical plotting. Okay, people that are working with data, they really need like high level control of how things are plotted and the different ways to visualize the data. It's very important for them. And yeah, so what we're working on, I'm hoping I can tell about the roadmap. I'm hoping that they are going to be announced, if not this month, next month for sure. So one who is working on them is actually Sean, so it's not me, and it's about neural networks. So we mentioned this in the announcement. So Sean is looking on higher level abstractions for building neural networks. Yeah, so when we released the Next, we had an example of building a neural network from scratch. So we want something higher level than that. And Sean is working on it. That's one of the projects. And the other one, it's almost ready. And we have a designer working on it to make sure that everything in there looks good. So that's the hint I can leave here. It's there's a designer involved, and maybe some live view stuff. We'll see.
Excellent, man. I've like you. I have a math background in my past, and didn't get to use it right out of college, but I'm interested to scratch that itch. So one of the types of neural networks that is one of these configurable models, right, or functions, is a recurrent neural network, and this is a kind of neural network that builds in a little bit of memory. So there's a question that talks about, that says, I'm very interested in using NX for music generation. Recurrent neural networks are commonly used in these efforts, in particular, long short-term memory networks. Are these already supported in NX?
So the question, I believe the answer is yes and no. So we have bindings for XLA. And we have mapped almost everything that XLA provides, like 95%. So it means that almost everything that TensorFlow uses to build its neural networks, it's already there in NX. So I would say from this perspective, the answer is yes, the building blocks are there, right? But the question is, how do we get from those building blocks to actually have this recurrent neural network running? And I think that's something that Sean is working on, like so you can so now we have, like really small Lego pieces, and Sean is working on making those Lego pieces a little bit bigger. And when we have that, I believe we're going to solve this problem. One of the things that you can do is that you can join us on the machine learning working group from the Erlang Ecosystem Foundation and ask those questions there. Because, for example, I'm not like, I know they were working on neural network library, but if you say how I'm going to model this problem, I actually have no idea. But I know there are people there that they know this really, really well, and they'll be able to point to examples. And if you want to get started today, maybe you can get started today if they give you the direction. That's a great question.
Yeah, I love that question. So here's one that's on the top of my mind as a company that likes to teach technology and make it accessible. Are there any tips for Elixir developers who don't have a math background but want to be prepared to work with NX? In other words, teach me math, please.
So I I don't know, because I've been kind of like learning everything again from scratch. So I'm not the best person to answer that, just because my knowledge is so outdated and now I'm just catching up to things. The part of the good things from this is that part of the good things that, like NX is meant to take like some of those concerns from us. So I'm going to, so you don't have to worry about the low level details, right? So I'm going to tell this story just as an example, which is, so for example, we added this thing that we called autograd or derivatives to NX, right? And why do we have this thing? So just to give an example of how the math is used and how you don't have to in many ways, you don't have to worry about it. So our goal, so if you think of a neural network, something that has input and output, our goal is to, when we give a cat to this neural network, for it to say, hey, it's a cat. So we know what we want our neural network to output, and we know the output that it's giving us when we call that thing. So we know when we know when our neural network is right and when it's wrong. And what we want to reduce is that, if we define some loss function, like, hey, if we went very simply, say, hey, when it's wrong, I want to return, like, I want to say that the loss is 1. When it's right, I want to say that the loss is 0. You can define a mathematical function for that. And basically what you want to do is that you want to make the loss to be 0. You want to reduce the loss, right? So the equivalent that I like to do in this story is like, imagine that you are at the top of a mountain and you want to go to the bottom as quick as possible, right? What you do is that you look around you and you give one step. You see the steepest slope down, and you give one step in that direction. And then you do that, and then you're going to be at a new position. You do that until you get to the bottom. And that's what the gradient does. And that's how we can train neural networks, because we have this idea of how to minimize the loss and compute this. And there is a lot of, and in order to implement that, we actually need to go like for each operation in X and implement the mathematical formula. So that was my first year at university right there. Like, you have to implement the mathematical formula for each thing. Like, what is the derivative for exponential, the derivative for log. But the good news is that you don't have to worry about that. You know, in a way, you don't have to worry about, you don't have to know about derivatives to use an X, because we're going to take care about it from you. But there are a bunch of other stuff that I don't know, and I'm trying to learn. It's like, for example, when you have a neural network, you actually have multiple layers. And those layers, you have to connect those layers somehow. And then you use different formulas like ReLU, like softmax. There is a bunch of stuff. I don't know any of them. But usually, a lot of the discussions then they stay at the high level. They say, hey, you should use softmax when you want like this kind of problem. So for example, if you want to say, is this image the number 1, 0, 2, or 3, then there are already like some prescribed properties of those functions, so you can kind of plug them in without knowing too much about the mathematical details, and just giving some mathematical idea. But yeah, so I don't think there's a good answer to this question. But what I'm trying to say is that, yes, I think there's a good amount of math, but I think we can sometimes try to approach instead of trying to approach it from the bottom up, which can be very complicated. I think we can probably approach it from top down. So, like, hey, you can look at the major blocks and try to understand why those major blocks they are there, and then try to look, and maybe how they are plotted to try to understand a little bit better, without us having to have like that very fine-grained control logic over how the math actually looks like. I think a lot of the times you're going to be working for like prescribed building blocks, unless you're doing research, and that's when you really, really care about like the very fine-grained details of the math.
Wow, what an excellent answer. So I gotta share with you, Jose, that as I was listening to your Thinking Elixir podcast, I had my list of things of wish lists, because I've been kind of researching some of this too. And the one I was saying, man, Elixir has the perfect abstractions for the autodiff or autograd stuff. And I kept on saying, yep. So you kept checking everything on my list that I was going to show you, and my email got shorter and shorter. I said, the last one is autograd. You announced that. And So I made some kind of noise where Maggie said, "What?" It was loud enough, and I was surprised enough. This was the announcement that got me excited. It makes Elixir a player in this space. It's the thing that you really have to be really a step beyond credible in this space. So really cool work. There's another great question. What are the chances that we're going to improve the non-ML math story for Elixir? Things like support for not a number and wrapping the Erlang standard math functions, basically just addressing the weaknesses of the core runtime without needing the full package of XLA, BLAS, or other algebra ML packages.
I love this question because that's something that we are working on right now. So for Erlang 24, the one that is currently in release candidate, go try it out. It's amazing. We added support for floating point 16 array, so for encoding in the binary. So in the binary thing, we have we can now, previously we could encode float 64 and float 32. We can now encode float 16. And I have 2 pull requests open. One, I hope it can be, I ask if it can be merged in time for TP24 because we really need it. So there are many ways of doing rounding. And we know the usual, like, the floor. So if you read like the float specification, they don't say about floor and ceiling. They say, they say like rounding to infinity, right? And that's our ceiling, right? And they say rounding to 0, that's our floor. And the rounding that we have today, which like it may go up and down, you actually have 2 ways of doing that. You can, when if it's tie, when there is a tie, for example, 0.5, does it go up or does it go down? You have 2 options. You can tie to the closest even number, or you can tie away from 0. And the IEEE spec says that the recommendation is to tie to even. So 0.5 should be 0 when you round it. It should not be 1. But if you try rounding Elixir in Erlang, it's going to go to 1. And the reason for that is because when C started, they rounded to 1. And a lot of the things are built on top of C and how C works, right? And then just later when the standards, the C standard start to become more and more of a thing, and the IEEE standard start to become more and more of a thing, they eventually figure out, hey, it should actually tie to even. And so there's a pull request that adds rounding to even, and it's going to be important because otherwise we are going to behave differently from all the other machine learning libraries out there. And I also have a pull request. So today you cannot get a float infinity or a float none in Erlang or Elixir. When you try to get those values into the system, it always raises. So if you, if you compute like there are a lot of operations that, so the spec talks about like, it's not that you're always going to get infinity. There's like the undefined infinity. There's there are some things where if you compute those, I think like the log of 0, I don't remember. Anyway, there are a bunch of mathematical formulas that they return infinity by their definition. And every time we get those in Erlang OTP, it always raises. It never lets infinity go into the system. And I have APR for that. And I believe it's going to be, not going to be included in time for Erlang OTP 24 because I think it's a big change. We have to kind of review everything to make sure that, so for example, if we allow infinity in the system, and now you pass infinity to round, what is that? Is that still infinity? So you have to kind of look at everything and write a bunch of tests. But I'm hoping as a consequence of this work, we will be sending contributions to Erlang OTP and to improve those things and make the whole ecosystem more coherent and consistent. One of the things that, for example, I'm wondering is like at some point we need to support complex numbers. So one of the discussion that we need to squeeze at some point is like, hey, how do we want to support complex numbers? Are we going to support them natively in the VM, or we're going to have an abstraction on top of it? I have been doing some research today to see how different languages they support it. And it's a discussion we need to have. And I think we'll be fine anyway. we'll have to add those to the language one way or the other. It's just a matter of how we want to implement it. And I've been thinking, like, for example, in Elixir, we try to make all the language constructs, we try to make them like not hard coded into the language. We try to make them a construct that all the developers can use, right? So for example, in Elixir, if you can write like if you want to have like complex numbers, like 1 + 2i, where I is the imaginary part of the complex number, how we are going to change the language. So, any Elixir developer can implement that I in the way that they want and not make that hard coded to the Elixir standard library itself. So there are a bunch of interesting stuff. I think it's going to happen. There are even like more mundane examples. So I like to say, like, I figure out that we don't have a power operation in Elixir. Most languages they have, but we don't have one in Elixir. And it's kind of funny that it never popped out, right? Because we're not really doing a lot of power operations. So and that's probably something we'll have to add as well. So there are some small things, but yeah, a couple. There's definitely going to. I think we are going to. That is going, like, as we work on all of these, it's going to improve things, even if you're not working, let's say, with multidimensional arrays.
Wow, great answer. So I'd like to give you one, I think we're just about out of time, but I'd like to give you an opportunity to put out a call to action. What are some of the places that you could actually use some help in the implementation of NX and things in the ecosystem?
Okay, so we need help with basically everything, to be very honest, because if we really want to start using Elixir for like machine learning, numerical computing, the amount of work it's a lot. It's a lot, right? So for example, I said we just talked about, somebody asked, like, is it going to be pandas and matplotlib? And those are two things that we need to have that we don't have, right? And then if you look at NX itself, if you look at the issues tracker today, I think we have 30 issues. So of all the projects that I work on, this is the one with most issues. They are usually really, really tidy, but it has a lot of issues because there's a lot of work to be done. And then I said that we are looking into neural networks, but that's not the only thing about machine learning. We have unsupervised learning, we have supervised learning, and then maybe we want to have abstractions for sparse matrices, right? So there's a lot of work to be done. So if you have an interest on this area, there is a lot of things that you can come and play with things and try to see, how can we establish, for example, the library for unsupervised learning or the library for clustering and so on. So there is a lot of things to do in that area. And I always say code is only one of the aspects for all of this, right? So as soon we're going to need people like writing about it, giving talks about it, as soon as things become a little bit more, let's say, stable. And then, so that's one of the ways we need people to use the tools, because if nobody's using the tools, what is the point? And if you don't get this feedback from users, then we're not going to be able to improve. So if there is a problem that you can play with it, that's even if it's not complete, but just to try some ideas out, that can give us very valuable feedback. And yeah, and talking about it. So I released when we announced the NX, I released a blog post, like NX is officially announced, they're unveiled or something like that. And there I cover some of the areas where we'll need help, or not necessarily help, but where I think people can explore and find interesting things. So yeah, there is a whole like banquet in here of things to explore and things to do. So if that's an area that you enjoy, I'm sure you're going to find areas. And join the machine learning working group in the Erlang Ecosystem Foundation. We have a lot of people talking about those things there. Even if it's not necessarily machine learning, numerical computing would be perfect in there because it's just very related. So yeah.
Thank you so much, Jose. This has been a tremendous conversation. Thanks for your work. Thanks to all the people who have contributed to the success of NX. And you heard it here that there are lots of opportunities. You don't have to know a lot of math to get involved. There are going to be a lot of opportunities to help. Thank you so much.